Introduction to Solving Inequalities. Part 1.
What are inequalities? I don't get it.
Do you remember when we talked about the fruits on the balance beam in Miss Avila's class?
Kind of. Can you show it to me again?
Of course, Mai. Do you remember when Miss Avila said,
We have a balance beam with fruit. On the left side of the balance beam, we have an orange and 4 strawberries. On the right side, we have 8 strawberries. Let the orange be our variable x and the strawberries are constants. The balance beam shows that an orange and 4 strawberries weigh less than 8 strawberries. We want to figure out how much the orange weighs compared to the strawberries. So to do this, we must isolate the orange. How can we show this? Well, if we take away 4 strawberries from each side, we can conclude that an orange weighs less than 4 strawberries.
let's try another problem now, but this time you're going to explain it to me. So suppose we have the problem x minus 2 is greater than 5.
Okay, so I know that first I need to isolate the variable x. I will do this by adding 2 to both sides of the inequality, like on the balance beam. This will leave me with x is greater than 7.
Nice, you got this.
Now I feel a bit better about inequalities. Thanks, Gilbert.
Part 2.
Can you check my work for problem number 5? The problem is negative 2x plus 5 is greater than 1.
Let's see. What did you do first?
First, I subtracted 5 to both sides of the inequality.
So your original problem is negative 2x plus 5 is greater than 1. Then you subtracted negative 5 on both sides of the inequality. So you left with negative 2x is greater than negative 4, right?
Yep, then I divided negative 2 to both sides of the inequality. And my final solution is x is greater than 2.
That is wrong. You have to switch the inequality sign.
Why?
Well, let's remember back to what Mrs. Avila said. Remember when she asked us?
Which number is greater, negative 1 or 2? Yes, 2 is greater. Now, what if we multiply both numbers by negative 1? What happens? Well, we're multiplying by a negative, so it turns the product into its opposite. Looking at the number line, the point on negative 1 moves to positive 1. And then the point on positive 2 moves to negative 2. Does the inequality sign still hold true? Well, let's think about it. Is positive 1 less than negative 2? No. What must happen to the inequality sign then? Well, the inequality sign must change direction to make the statement true.
Okay, I get it. So when you divide or multiply by a negative coefficient, we need to switch the inequality sign.
The end.